Hello world, Boolean Maths here. How's it going? So today I would like to talk about a really important topic known as trigonometry. Sometimes it seems intimidating to people. It really isn't. It's actually quite an elegant and beautiful topic. So if you're watching this, you've probably heard a little bit about this already. You've probably heard about SOHCAHTOA. You learned about the sine of an angle, the cosine of an angle, the tangent of an angle, right? So I'm assuming you have a little bit of background on this. If not, I'll try my best to make it seem new. So the idea behind trigonometry is that if you set up camp or you decide to choose one of the acute angles in a right triangle, right? There's two acute angles in a right triangle, right? You have the right angle and the other angles have to be acute. So if you choose either one of them, either A or B in this context, you can say that if this is big angle A, across from angle A is side A, little a. You could call it side BC, but it's easier in a triangle to name a side based on the letter that it's opposite. So if you notice, C over here is opposite big C, so on and so forth. Okay, so relative to side A here, angle A here, this is the side that's opposite A. And then right here, we have the side that's adjacent to A. And both the side that's opposite of angle A and the side that's adjacent to angle A, that's all relative to A. Then of course we just have the hypotenuse. The hypotenuse is always across from the right angle. We know what that is. That doesn't change no matter how we look at this triangle. So now that we have established relative to angle A what the opposite side is and what the adjacent side is, and of course what the hypotenuse is, we have these three trig ratios that emerge. We have sine, cosine, and tangent. So the sine of angle A represents a fixed ratio, and that's going to be the opposite divided by the hypotenuse. You know, it would be kind of fun if I could pick out some highlighter colors that are somewhat consistent. All right, and now we'll go reddish on this one. All right, cool. So like I said, we have opposite over hype, then we have adjacent over hype for cosine, and then the tangent is going to be opposite over adjacent. So that's all well and good. I think this is a great reference, and you can look back at this and it'll make a lot more sense in the future. So let's just, I'll show you a quick explanation for like how trig actually works. So a really great example of that would be using a 30, 60, 90 right triangle. This should ring a bell. And so we can say, let's just call this a 30-degree angle. And here's our right angle. That means that this is our 60-degree angle. So just for fun, I'm gonna take this, cut it, and then we're gonna paste it. Make a little tiny one here. Then I'm gonna paste it again. And as you notice, it's just a bit bigger. One thing that we know about both of these triangles is that they are why are they similar? AA. All right, so just for fun, we will call this triangle A, B, C, and we can call this one P, Q, and R. That means across from A, angle A, we have little b, little c, and then across from P we have little p, across from Q, little q, and across from R, little r. So that's worth noting. Now, just for giggles, I'm going to take side C here. I'm just going to replace it with make it purple. I'm going to call this 4. And if that's 4, we know across from the 30-degree angle, it's the short leg. It means that A is going to equal 2 and B is going to equal 2 root 3. If you're curious about this, please either see another video in the library here or Google another video to learn about 30, 60, 90 right triangles. You probably should have learned about that before doing right triangle trig. I'm going to replace side R over here with the number 8. So if this is 8, that means across from 30 again is the short leg, half of the height. This is 4, and our long leg is going to be 4 times the square root of 3. All right, so I think we can all agree that both of these triangles are similar. The scale factor is 4 to 8 or 1 to 2 for both shapes. All the sides in this right triangle, and the triangle on the right, are twice the size of the triangle on the left. Now, one thing that you know about similar triangles is, of course, you could match the corresponding parts. I could say the hypotenuse is to the hypotenuse as the short leg is to the short leg. Again, you'll see the scale factor there. But the other thing that you could do, and some of you have done this, I've seen my students do this, is you could say, well, I know that the height is to the base of this triangle as the height is to the base of the other triangle, right? So I'd be like, if the height is to the base, it'd be 2 is to 2 over root 3, which equals 1 over root 3. And over here, I'd have 4 is to 4 root 3, which is, again, 1 over root 3. They're in the same ratio. So if you're likening or equating the same types of parts, you're comparing apples to apples in one shape, then you're going to be comparing them apples to apples in the other shape as well. So what do I mean by that? Well, so we just learned that the sine is going to be the opposite over the hypotenuse, right? So relative to angle A and angle P, this is our opposite. This is our adjacent. This is our hype. Adjacent is always right next to the angle that you're looking at, and the opposite is of course across from it. Here's the opposite of this other triangle PQR. Here's our adjacent right there, and then we have our hype. So if I were to look at this triangle on the right and say, what's the sine of angle A? You'd be like, all right, well, that's SOHCAHTOA. Sine of an angle is always the opposite over the hypotenuse. So, well, that's a 30-degree angle, right? So rather than call it angle A, let's just call it 30, right? Because we actually know its measurement. So 30 degrees. So sine of 30 degrees in this triangle over here, triangle ABC, is going to be opposite divided by 4. Which equals 1/2. If we look at this triangle over here and we do the same thing, what's the sine of 30 degrees? I'm going to do my opposite, which is 4, over hypotenuse, which is 8. That's going to be 1 to 2. Again, you notice that the sine of 30 is the same in both of those situations. Now, the sine is actually a function. It's called a trig function. If we were to go to a calculator and say, what's the sine of 30 degrees? Notice how I have degrees or radians. I could toggle between them. We want to make sure we're in degrees. Look at the answer. The answer is 0.5, right? And that's 1/2, which is what we have over here. So that's a fixed ratio. No matter how big or small the triangle is, relative to a 30-degree angle, the side opposite divided by the hypotenuse will always be 1/2 for a 30-degree angle. That's going to be different for other triangles, but you have fixed ratios. And we talked about similar, right? With AA, as long as you have two angles in a triangle, right, that are congruent to two angles in another triangle. So if I'm looking at just these two angles, the 30 and the 90, the 30 and the 90, that's sufficient for knowing that I have similar triangles. So if I had a 57-degree angle and a 90, all sine of 57s will be the same. So that's something to consider. All right, so you could do the same thing with the other trig functions. I don't want to take too much more time, but because we should just do some examples. Like the cosine of 30 is going to equal adjacent to root 3 over hypotenuse, which is going to be, this will reduce down to the square root of 3 over 2. Cosine of 30 on this triangle is going to equal adjacent 4 root 3 divided by 8, which reduces to square root of 3 over 2. If I were to go to my calculator over here and say, what's the cosine of 30? You get, oh, this weird number, 0.86602 whatever. That's cool, but we also know that we got, and that on the special right triangle that we're familiar with, the square root of 3 over 2, and if you look at that answer, it's the same thing as the cosine of 30. So again, no matter how big or small your triangle is, the cosine of 30 will be the same by virtue of all 30-degree 90 triangles being similar. So the adjacent to hypotenuse will be fixed. It'll just be in a different scale, but it'll reduce down to the same thing. And the same thing goes for tangent, and you could play with that later. All right. So now they want us to just list the ratios for the sine, the cosine, and the tangent of angle A. So it's important that you identify the angle that sets up your vantage point, and then I would just label relative to that angle the adjacent. Again, you have your training wheels on. It's worth doing this right now. The opposite, and then the hypotenuse. So now that we have that, they just want us to write down what those ratios are. So you'd say the sine of, and because we don't know what angle A is, we're just going to go A, then we're going to say the cosine and the tangent also of angle A. If you know the number, then you would put it there, but we don't know the numerical measurement of that, and that's totally fine. You're just writing the variable representation of that angle. So for a 3, 4, 5 triangle, it's a Pythagorean triple, familiar. The sine of angle A in this case, that's across from the 4, will be 4/5. That's opposite over hypotenuse. Cosine will be 3/5. Tangent would be 4/5. Okay, that's relative to angle A. What if they said, find the sine, cosine, and tangent of angle B? So I would ask you now to pause the video and relabel the diagram. It's funny, I do this all the time. I said B, right? I gotta fix that. Let's make that angle C in this case. Normally the C is the right angle, right? And they messed with us on this one, but that's okay. I caught it. So we can only do sine, cosine, and tangent of the acute angles, at least at this point. Okay, so pause the video and find the sine, cosine, and tangent of angle C. All right, welcome back. So relative to C, this is now the opposite. This is now the adjacent. And this is, of course, going to stay our height, but it's fun to color it all in blue. So the sine of C is going to equal opposite over hypotenuse, 3/5, cosine of C, adjacent over hypotenuse, and then tangent of C is just going to be opposite over adjacent. Okay, so it all depends on the angle for where your that establishes what I would call your vantage point. So that's from where you're standing. Sometimes I say I'm setting up camp at that angle. So it's either going to be angle C or angle A, because those are the acute angles in this diagram. Okay, so why are we learning about trig? Well, trig makes it possible for us to find missing measurements in a right triangle when you only have an angle and a side. So let's look at this example 2 over here. So they want us to actually find the missing variables. They give us angle 32 degrees. We don't even have any letters on the angles right now. We're just have a bare right triangle, and we're just solving for x and y. So now it's really important that we establish that's our vantage point. And then I'm going to say that this is opposite, this is my adjacent, and here's my hypotenuse. So like when you're solving any problem, it's important that you write down the relationships that you know. So the relationship that we know here is that the sine of 32 is equal to x over 18. So x is our opposite, 18 is our height. Notice we only have one variable, that's good. If you had said, tangent of 32 is equal to x over y, you have a problem. You have x and y in the same equation. So you really can't use tangent for this particular instance. So sine works out. So you want to ask yourself, okay, for SOHCAHTOA, right? So, let's do a color change. So, ka, and then toa. Okay. For SOHCAHTOA, opposite hypotenuse, adjacent. So we have again, we'll highlight these guys. So we have sine is associated with opposite and hypotenuse, cosine, adjacent and hypotenuse, tangent would be opposite and adjacent. So in this diagram over here, I need to find x. So that's an opposite. So I'm either using sine or tangent, right? But now I have to look at a side that I know. You need to know at least one side. Well, I don't know the adjacent, so I'm not going to use that because I'm trying to find the opposite. But I do know the height. So I say, of these 3 options, which one involves opposite and hypotenuse? That's sine. So when I go to solve for y, right, I'm not going to use x too. I'm going to just use y. So I need a trig function that involves adjacent and hypotenuse. So when I go to solve for y, I need to find the adjacent, but I need to know something else. So I happen to know the hypotenuse. So which trig function involves adjacent and hypotenuse? Not sine, cosine, right? AH, adjacent and hypotenuse. So that's what we would use for that. So you could write also that the cosine of 32 degrees is equal to y. We'll color code our variables. Y over 18. Okay, again, this looks a little bit weird, but this is something that you technically have a proportion that you can solve. So let's focus on sine of 32 over here. So we know the sine of 32 is equal to x over 18. Great. Well, I'm going to come over here. I'm going to figure out what the sine of 32 is. So I'm going to go sine 32. Okay, that's equal to 0.5299. 0.5299 equals x over 18. If you want, you can throw that over 1 so it feels more like a proportion, and then you can solve. This number right here, sine of 32, is in fact a number. It's a decimal that represents the opposite to the hypotenuse. Okay, so you can write it in decimal form. Notice I used 4 decimal places. Okay, always four decimal places. Frankly, I don't really like to write the decimal out at all. The next one that we do, I'm gonna not use the decimal, but just letting you know that it would be 4 decimal places. And if we were to go ahead and solve this right now, just cross multiply, and you get x equals 18 times 0.5299, which is going to be approximately equal to, go over to our calculator. So I can say 18 times whatever that other answer was. It's nice, it gives us a nice long decimal, and it's 9.54. 9.54. What did I say? Do I round to the nearest tenth? Okay. So it's just 9.5. Yeah, that works. Okay, 9.5. So yeah, so this side over here is supposed to be, it's about equal to 9.5. Some of you may be like, oh, cool, look, I know one leg and I know the hypotenuse. I can find the third side. You absolutely could do that. However, this is an approximation, so you might not get the greatest answer. If we go back to our original given information, we'll have a lot more accuracy. Okay, so with this next scenario with cosine of 32, I know that the cosine of 32 represents a number. Okay, I can go look over on my calculator and say, okay, what's the cosine of 32? And it's going to tell me it's 0.8480. So I know that this is 0.8480. Now that's really annoying to have to write down the decimal, and be sure to write it to 4 decimal places, because it's important that we keep that level of accuracy. If you round that, your answer is just not going to be that great. If you rounded this part to tenths, that would be horrible. That's another question that some of you may have. It says, hey, look, it says round to the nearest tenth. That's round your answer to the nearest tenth. If you're using something else and you're multiplying by that number, you need to round that to at least 4 decimal places. That's kind of standard for any number that gets rounded. But we have the option, especially with calculators nowadays. I'm just going to leave this as the cosine of 32 because I know it's a number. So I'm going to take that cosine of 32, I'm going to write it over 1. Look, I have a proportion. Let's solve it like a proportion. I just need you to remember that this is a number and you treat it as such. So we're going to isolate y. We're going to solve for y. So I'm going to cross multiply. And what I get is y equals 18 times, and just for fun, I know I'm switching colors. Maybe we'll just color this right now. We'll color it green so it feels a little bit better for consistency. And then I'll write here cosine of 32 degrees. So that's an exact answer. I know what y is, and it seems weird, but I'm going to just go like this. Now I'm going to make it an approximation. 18 times the cosine of 32. 18 times cosine 32. So you can see that you can enter it right into your calculator like that, and I get 15.3. And there it is. That's going to be about equal to 15.3. So how do you think you could check your answer here? Pause the video for a sec once you think about that. All right, welcome back. You're right. Let's just see if the Pythagorean theorem works. Now, of course, these are both fairly crude approximations of what the actual measurements are, so we're just going to have to deal with that. But let's go 9.5 squared plus 15.3 squared and see, does this equal 18 squared? So 9.5 squared plus 15.3 squared. What is 9.5 squared plus 15.3 squared?
The answer is 324.34.
324.34. 324.34. What is 18 squared?
One moment.
We're waiting.
Still trying. 18 raised.
Okay. And that's going to be 324. So, yes, it's about equal. That's good enough. I mean, we rounded those other answers, so we know we got it right. I'm not saying you have to do that every single time, but, you know, if you want to make sure you're getting the answers correct on a test, that is accurate. We definitely found those missing sides. All right. As usual, these videos always run a little bit longer, but, you know, hopefully this will all be useful information for the viewer. Okay. Here's another scenario. So I think you should probably pause the video and see if you can do this on your own. So why don't you do that? My advice to you is to only use the calculator for the last step. Okay. So all right, pause the video. See what you come up with. All right, welcome back. All right, let's see if what you got matches what I've got. So they gave us angle 43 here, 43 degrees. We know that this is our opposite, this is our adjacent, and this is our height. Okay. So I know that from even that previous example, that if I'm trying to find, in this case, the opposite, okay, maybe it's worth, again, stating good old SOHCAHTOA. So I'm just going to copy that and I'm paste it over here. Why not just paste it in every time? So of the three trig functions listed there, SOHCAHTOA, which one involves opposite and height? Because I don't know the opposite, but I do know the height. So once again, we're going to start with sine. So that means I'm going to go sine of 43. You know what? You don't even need to write the degree symbol at this point because you're going to just be doing all these computations. We know we're dealing with degrees. Is equal to s over 26. I'm going to toss this over 1, cross multiply, and I get s equals 26 times sine 43, which is going to be about equal to, so I'm going to go 26 times the sine of 43. And that's going to be equal to 17.7. And then for tangent, we know, I'm sorry, not tangent, but for the other trig function we're going to need involves needing to find adjacent and knowing the hypotenuse. So which of these has an A and an H for adjacent and hypotenuse? Cosine. So just like the last example, actually, we're dealing with cosine and sine again. So we know that the cosine of 43 represents the adjacent to hypotenuse ratio. Put that over 1, cross multiply, r equals 26 times cosine of 43. So that's the exact answer, but let's get the approximation. 26 cosine 43, 19.0. I don't really feel comfortable writing 19.0, so let's say 19.02. So we have a 19.02. And there you go. So we know that side S is about equal to 17.7 and side R is about equal to 19.02. I'm pretty confident that we got that right. I'm eager to move on to this last one and call it a day. I will advise you, though, to check your answer using the Pythagorean theorem. And if you get, again, an approximation of what the Pythagorean theorem is with these rounded sides, you're definitely doing the right thing. All right, lastly, here we go. So they give us this angle here, okay? I'd like you to pause the video and see if you can figure this out. Let's paste our SOHCAHTOA in. So go for it. Video's paused now. Okay, welcome back. So we have, relative to this 50-degree angle, we have the opposite across from there, adjacent, and then our hype. So things are a little different this time. So we're gonna just draw a little circle again for highlighting stuff. So I would like to find this adjacent side right now. I don't know the adjacent, but I have the opposite, right? So we have a given and a non-given. So I need a trig function that involves the opposite and adjacent, right? Because I don't want to use adjacent and hype. Cosine's off the table this time because they're both unknown. So, but I need something that involves adjacent and opposite. That's an O and an A. So TOA, that's O and A, perfect. So let's use that. So I'm going to put my little highlighter over there, and here we go. So that means we're using tangent. The tangent of 50 degrees equals opposite, which is 8, over adjacent, which we're calling M. Okay, and we'll call it we'll make the M green. Okay. So once again, we're just gonna cross multiply here. So when I cross multiply, this is gonna look a little different than some of the other ones because we have M times tangent of 50 degrees equals 8. That tangent of 50 degrees is a number, right? So I need to solve for M. I need that by itself. So if it's M times tangent of 50, that means I would divide both sides by tangent 50. Divide by tan 50, divide by tan 50. Tan 50 is a number. That divides out, so I'm left with M equals 8 divided by the tangent of 50, which is approximately equal to 8 divided by tangent 50, 6.7. Great. Let's look back. We still have to solve for n. That's our hypotenuse. So we know the opposite and we need to know the hypotenuse. That's O and H. So which trig function involves O and H? There's OA, AH, OH. So we have to use sine for this next one. So I'm going to come over here and I can eliminate my little circle there. Great. And I'm going to say the sine of 50 equals opposite. It's 8 over my hypotenuse, n. So let's start solving. I'm going to toss this over 1 so I could just feel the cross multiplication coming on. Say cross multiply. And once again, you get this awkward situation where it's n times a trig function, which again represents a number, equals 8. How do I isolate that? I divide both sides by it. So I'm going to say divide by sine of, when I say it, I divide both sides by the constant that's multiplying my variable. Sine 50. Okay, so that means that n is exactly equal to 8 divided by the sine of 50 degrees, which will be approximately equal to 8 divided by sine 50. 10.4. So there you have it. We know that M is about equal to 6.7 and side N, our hypotenuse, is about, N is about 10.4. Well, I hope this video was helpful, and there'll probably be more videos related to this in the near future, especially when it comes to using trig for solving word problems and also using it for finding missing angles. That's going to be another future topic. So thanks for watching.